Today we're going to learn about the distributive property of multiplication over addition. And that is the official title, so you've probably heard of it as just the distributive property, but it is the distributive property of multiplication over division. Our learning target today is to identify and apply the distributive property on real number expressions. This should be page number 18 in your notebook. The distributive property states that you may multiply a sum by multiplying each term separately and then adding the products. So if you look here, we have the mathematical definition, A times B plus C. So what this definition is saying, or what this property allows us to do, is we have this sum right here, B plus C, and since we can't add B plus C because they're not numbers, we can't simplify that. What they're saying is the distributive property allows us to multiply this factor to both terms individually. So you can see here, A times B, A times C. And then adding the two terms together is the same exact thing as just adding them first and then multiplying them. So this distributive property is something that we use when we can't simplify inside of the parentheses. However, in this example right here, I'll show you that it works even when you can simplify inside the parentheses. So we have the same exact expression here. On the left side, I'll distribute, and then on the right side, I'll simplify according to order of operations. So if we follow this distributive property, so I can go ahead and multiply this negative 2 to each of the terms. Now when I do this, note that this is the distributive property of multiplication over addition. It does not say anything about subtraction. So technically what I'm doing here is I'm multiplying this, or I'm turning this negative 5 into a plus a negative 5. So then when I multiply, it's not distributing over subtraction, it's distributing over addition, right? So we have negative 2 times 3 plus negative 2 times a negative 5. So this is what we write when we distribute. And we can go ahead and simplify this further. Negative 2 times 3 is negative 6, and negative 6 plus negative 2 times negative 5 is a positive 10. And we know that negative 6 plus 10 is a positive 4. So when we distribute, we get a positive 4. And then when we simplify over here, using order of operations, we can go ahead and simplify the parentheses down first. So we have 3 minus 5 is a negative 2. We bring down this times negative 2. And negative 2 times negative 2 is a positive 4. So you can see we get the same exact answers when we distribute as we would when we use order of operations. And so distributing really only applies to when there's unknowns in the parentheses, because when there's just numbers, we can simplify the parentheses first. So we only really distribute when there's a variable inside the parentheses that we can't simplify. Here are a couple examples of common mistakes. The first common mistake is distribute only to one term. This happens all the time where a student will see negative 3, they'll multiply it to the x, and then they'll forget to multiply it to the second term, and they'll rewrite it as negative 3x minus 5. So distributing only to one term, if there's two terms inside the parentheses, is incorrect. Or adding. See students add all the time. Well, they'll see, oh, negative 3 and x, that's just a negative 3x, which that's not even proper addition anyways. And then negative 3, negative 5, they'll see negative 8, or maybe they'll just see 8. So adding is incorrect. Distributing only to one term, incorrect. Or forgetting to distribute the negative 2. That would be another common mistake. So here we have distributing a monomial to a binomial. And a monomial to a binomial just means one thing to two things. So you can see here we've got one thing that's going to be distributed to two things. Here's our one thing. We've got this 2x times the parentheses. Here's our sum. And we can go ahead and multiply this 2x to both of the terms inside of the parentheses. And we can rewrite this expression as 4x plus, we've got 2x times a, and then remember we've got a plus 2x times a negative 3. And I always write the 2x before I write the terms because you multiply from the left to the right. So the 2x is being multiplied on the left. So it's listed first, technically, right? I could switch them around using the commutative property, but we're only focused on distributing. And then we could simplify the multiplication if we wanted to even further. We could say, okay, this is the same thing as 4x plus 2xa plus, or we can multiply 2 times negative 3, that's negative 6, so we can say actually minus 6x. So we can simplify it like that, right? So here we have another example. We've got 7x to the third plus 2 in parentheses, and negative 4 or minus 4 times x plus 2. And you can see that this negative 4, right, we can turn into a plus a negative 4. So this negative gets distributed into the parentheses. And we're distributing it to what it's being multiplied. We can't distribute this other way because it's not being multiplied to the first set. It's being subtracted, right? So the second set is what it's being multiplied to. So we can rewrite this as 7x to the third plus 2. And then we have plus a negative 4 times x plus a negative 4 times 2. Right, and I've got double signs, but not to worry. And we can simplify this as 2 in parentheses. Negative 4 times x is just negative 4x. And then negative 4 times 2 is just a negative 8. So we can simplify it to this. Last example. In this example, we have the parentheses and then times 5. So we're normally used to distributing when the factor is on the left and the parentheses are on the right, but distribution can happen the other way. We can distribute this way, right? So we're going to distribute this 5. And what we get here is we get a, since a is listed first, times 5, plus a negative c times 5, plus x squared. And then we can simplify this to say, okay, let's just put it, let's commute these, 5a plus, and then let's commute these, negative 5c plus x squared. So that's simplifying when there's a monomial to a binomial. Now what happens when you simplify, or when you have to distribute a binomial to a binomial? So two terms to two terms, right? So we've got two terms multiplied to two terms. There's two different ways to distribute here, and it's very important that you only are distributing. We don't want to move anything around using the commutative property. We're only wanting to distribute. So the first way that we could distribute is if we took the parentheses on the left side. So if we took b plus x and we distribute it to a plus y. So what I'm saying is, here's our sum, and we're going to take this and we're going to multiply it to each of the terms inside the parentheses. And when we do that is we get b plus x times a. Sorry, that a is terrible. Plus, and we have the plus, b times x times y. So we can distribute the left set of parentheses to the right set, and we always make sure that we multiply from left to right. So when we multiply this b plus x to the a, since it's on the left, it's listed first in the multiplication. And then from here, now we can distribute the monomial to the binomial, or the one thing to the two things. So now we can distribute this way, right, with both of these sets of parentheses. And what we'd get here is we'd get b times a plus x times a. And x is listed first because it's further left than the a. Plus b times y plus x times y. Then we can just simplify this and say, okay, this is the same, ba plus xa plus by plus xy. So that's the first way we can distribute. The second way we could have distributed would be to multiply the left set of parentheses first to the right set. So we have b plus x, a plus y. We can say, okay, here's our sum, right? Let's go ahead and let's distribute this set of parentheses to our sum. So if we did it this way, what we would have is b times a plus y plus x times a plus y. So I'm multiplying this a plus y to the b, and then I'm multiplying it to the x, and you can see that right here. And then we could distribute this monomial inside the parentheses, and we would get b times a, which would be ba, plus b times y would be by, plus x times a would be xa, plus x times y would be xy. And you can see that we have the same exact expressions, however they're in a different order, right? So there's two main ways to distribute, and these are both of the ways. So here we have complete the proof by rewriting the expression, and we're given this expression right here. We've got two binomials that are being multiplied, and our first step is going to be distribute. And what we have to do is we got to distribute in the way that's going to set us up to get this final expression. So from here to here, and then from here to here, we have to get this final expression without having to do more than two steps. So what I'm going to do is, we learned two ways to distribute. I'm going to do both of those ways because one of those ways is going to set us up for our final answer correctly, and one of those we might have to commute some more things so we know that that's not the proper order. So I'm going to do d plus v times m plus p, and with green I'm going to distribute the d plus v to the m and then to the p, and then with purple I'm going to distribute the opposite way. So I'll do d plus v, and I'm going to distribute this m plus p into the parentheses the opposite way. So if we're looking at the green expression, we've got to see which of these is going to yield the correct order of the terms. So we have d times m, so d plus v times m, so d plus v times m, plus d plus v, distributing this d plus v, times p. So here we have d plus, whoops, that p's terrible, there we go. And then from here, you can see we can distribute the factor on the right side of parentheses into the parentheses. So we've got now, and I'm making sure that the order I multiply is staying good. So d plus v came on the left, so when I multiply it to the set of terms on the right, okay, I make sure that the left multiplication is listed first. Likewise here, this m is going to be listed second since it's further right. So it's d times m, so dm, plus v times m, plus d times p, plus v times p. And you can see now, after we distributed once, this would be our expression. We distribute again to get this expression, and you can see this expression is the same exact as this expression. dm, oh it's not, dm, vm, this is not the same exact order. So this expression right here is no good because, well, it's not necessarily no good, but it's not setting us up to get the final expression that we're trying to get with only two steps. So let's see if the other way of distributing yields in the correct way. So we have d times m plus p, so we're distributing the m plus p, plus v times m plus p. So if we distribute this way, we can now distribute the d to the m and the p, and we get dm plus dp, plus we can distribute the v inside the parentheses, we get vm plus vp. And you can see now this expression is the exact same as this expression. So we know that the expression that we're typing in the first blank is this expression right here. And then from here to here, what did we do? We distributed again, so we can say that this is also the distributive property. And we can simplify distributive property in Schoology as just dp.